Okay, so today we're going to be looking at eyes on the solar system. We're going to use this tool to help us get a quick understanding and a tool to help us do our research on our planets of the solar system. And I want you to use this tool, Home, to take you each time out to the bird's eye view of the solar system. So the center of our solar system, we're a heliocentric solar system, meaning the sun is the largest body in the solar system in which we all orbit around the largest body of mass. Here are sunspots right now taking place on the sun. Now where I want you to get your information is up here. We've got stats, statistical information. So it tells you all sorts of different information: equatorial inclination to orbit, mean radius, equatorial circumference, key information, some volume, mass, okay, mass, 10 to the 30th power, that's 30 zeros after that 10. That's a lot of mass. Density, surface area. I want you to get all of this information. I want you to explain this information. So we got surface temperature of the sun, the surface, the top layer that you see is 5,500 degrees Celsius. Okay, so moving on from the sun, we press our home to go to our next planet, and here he is whisking around little Mercury. I want you to double click on Mercury, and here we find our rocky bodied first planet. All right, the first planet is a rocky planet. Click on stats. I want you to look at this range of temperatures. So looking at Mercury, our range of temperatures on Mercury is negative 173 degrees Celsius and 427 degrees Celsius. This is a very significant range of temperature. And we get our heat from the sun. So the side facing the sun is this whomping 427 degrees Celsius, which is far above the temperature to boil water at. But the significant part about this is in these craters, scientists have recently found through satellite data frozen water in these craters. These craters are so deep, miles deep, that they're inside these craters, it still never gets any sunlight on it. And with that lack of sunlight, that water is able to stay frozen within there. Pretty interesting stuff. So, moving on from Mercury, we head home, and our next planet is Venus. Venus is our twin planet. We have similar mass, similar size of Earth. And Venus is a perfect example of the significance of global warming. And if you look, our surface temperature on Venus is 462 degrees Celsius. Day, night, North Pole, South Pole, it don't matter. It is very, 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 very hot on Venus. Venus is so hot it will melt the actual element of lead, turn it into a liquid. The reason why Venus is so hot, not needing to be as close to the sun as Mercury and stay at hot, is how dense and thick its atmosphere is. Alright, moving on from Venus, we hit home. And here's our planet. I don't need to get too much into detail about our planet. All you need to know is here's the night side, here's the day side. I still want you to get the stats over here for the following the rubric of what information you're supposed to get. Here's our moon. If you want to give a quick look to it, go ahead and click on it and gander and find information. But we're not going to go too much into the moon on this broadcast. So moving on from Earth, our next planet is the planet where the scientific community has been really interested in. We have sent numerous land rovers to Mars to find out information. We found out information that there was once an abundance of water on Mars. This is what's gathered the scientific community to research and find and discover and explore what happened to the water, what happened to its atmosphere. If you look at the stats, you call it the red planet. People think red, so they think hot. It is actually very cold. It's very, very cold on Mars. It's negative 87 degrees Celsius to a negative 5 degrees Celsius. Now, this does not have to do with just the matter of it, the side facing the sun, getting the warmer temperatures, but it actually has seasons just like Earth. It's on a tilted axis, and if you looked at the elliptical orbit, there are parts of Mars on that orbit that is a little closer to the sun as well. Mars has 2 moons. As you can see, there's Phobos, and then over in this side we got Deimos. These are actually trapped asteroids that are stuck in its gravitational pull. They are non-spherical shaped as our moon is. It's just a little side information. So heading home to go back out into the orbit, the next planet in the solar system is Jupiter. We got there. Okay. So here's Jupiter in the background. I clicked on Callisto, which is one of the many, many moons of Jupiter. So here we got Jupiter. Okay, Jupiter is the largest planet in our solar system. It is also a gas giant, meaning we are not completely certain there is any rocky core material underneath this hundreds of thousands of miles thick of atmosphere. Stats for Jupiter, once again, are all located right here. And if you look at the temperature for Jupiter, 148 degrees Celsius, which is very warm still. Okay, one of the reasons scientists believe that it is such a large gas giant, but being so far from the sun, there's some theories out there that the reason Jupiter is this warm is because it makes its own heat. Right? And we'll go more into how a planet can provide its own heat later on in the semester. Okay, hit home, and we're going to wander out from Jupiter. And now we have to find outer gas giants. The next one after Jupiter is our ringed planet, our famed ring planet. Here is Saturn, right? Saturn is a very large body of mass. It is the second largest planet in our solar system. And what I'm doing is I'm zooming out so you get an idea of the moons. What makes Saturn so unique is there is actually 60 moons and counting on Saturn. And each one of these rings shows the orbit of Saturn, around Saturn. And so if you zoom out, you keep seeing more and more of these moons, but we're not going to go too much into it. It's just a interesting fact that Saturn has all of these moons stuck in orbit around it. And we look at our stats. We got all of our information here. Right, and we look at our surface temperature opposed to Jupiter. Saturn is very cold. We are very, very, very far away from the sun right now. Okay, and here's our atmospheric constituents. It's mainly filled with hydrogen and helium. Okay, so moving on. Our next planet out of the solar system is Uranus. Oh, what happened? Okay. Our next planet is Uranus. Here we go. Now, what makes Uranus so unique is this is a planet that rotates on its side. So, we will explain further on this broadcast. You may get a little confused, and that's okay. I'm not going to get into it too much right now. Uranus is a blue planet. It has some very cold temperatures on it. And here we are, negative 216 degrees Celsius. It is a great distance away from our planet, let alone our sun. So as you see, the going theme, the further away from the sun you are, the colder it gets. All right, moving on past Uranus, we have to zoom out. Zoom out. We're getting very far, and here's our farthest normal sized planet, Neptune. Right? So Neptune's a very blue planet. Neptune is very interesting. It's also, you see this dark blue spot similar to the dark red spot on Jupiter, on Neptune's dark blue spot. This storm, it's still a storm. It's actually showing up and disappearing at random places throughout the planet. And scientists are puzzled by this. How does this giant blue spot come and go at random times? It's very intriguing, very interesting. And once again, we have our stats and the going theme. The further away you are, you're pretty cold. And one of the reasons why Neptune is so blue is the not just the methane, but that methane with the combination of helium creates this dark blue. So very interesting. Okay, so this is all of the planets that I would like you to do your research on, and from that I would like you to explore destinations, missions, features, news, people. Okay, so add what other side topic you would like, and if you have any questions, just write it down on a piece of paper, leave it in my mailbox, and like always, I get back to each and every one of those questions. All right, I will